So for those of you who watched the last video and might have been thinking that the weird IV curves I got on these red packages, I know I've been talking so much about these diode blocks, but they're just kind of strange, so live with it. You might have thought that the strange IV curves I was getting was because it was in circuit and it technically has a resistor across it. And a resistor is a linear device. So realistically, it shouldn't matter. And that was my original thinking. It's a linear device, it's not going to affect the nonlinearity in the IV curve. So we should still see the same exponential growth from a normal diode. So just to double check that, I have disconnected the center tap on that diode block so we can measure both diodes separately out of circuit. And as you can see here, it's exactly the same. There is, it goes up a little bit higher, but this general, not slope, but the general curve is the same. So in-circuit effects, not really that big a deal. I can check the other diode again. So this is the other one in the package. And again, it looks basically the same. So no, it's not the in-circuit effect. It's just these are very shallow curve diodes. So I think I will put in a 1 in 4002 and just see how it goes. I looked at the schematic and it may detect really well. It may I think they're using them as sort of like detectors. I don't understand FM demodulation fully, so I'm a computer engineer. I do firmware, not circuitry. So I'm not entirely sure what they're being used for, but I think it may oversaturate the signal if I put in lower voltage diodes. But it doesn't hurt to try. It's not going to do anything bad if I put them in there. So I think I might change one of them. I'll just change one channel, right? Because there's one per channel. So I'll just change one, and then I'll run it, and I'll see which channel left or right performs better, and then I can make my calls to what I'm going to do. Now, one thing I thought I'd mention, because I think it's actually quite ingenious, is the way that this radio handles the tape input. Now, the tape input is designed to be capable of accepting both mono input from a single RCA jack as well as stereo input from 2 jacks. And it has to do this automatically. And for anyone who's ever had to plug in a stereo TRS jack into a mono TRS jack, you'll know that only one channel works, things like that. So I was wondering how they were doing the sort of detection and switching. And the answer is they're just doing it with a very clever design in the actual jack itself. And this is the jack right here in the corner, and this is the right jack. So the left jack is down here, and it's separated all the way over here. So that's why when you look at the top, you'll notice there's that big gap in between the left and right, whereas the others are all in pairs. And the reason for that is to do with this this extra wiring job that they've done here, and that's part of the stereo mono switching. So the way that they do this is, like I said, it's actually quite neat, and I can't say that I've seen it before. So you can see that there's these 2 prongs on the end of that connector, and unfortunately I can't hold a light at the same. Maybe I can do this. That's good enough. I think you can still see it. So anyway, what they do is there's the left channel is wired, basically the 2 grounds, or basically the outer sheath, is connected together, of course, because they're common. And then the signal from the left runs through one of these wipers, which is spring-loaded, so it's contacting the other wiper, and then from that wiper out. So what happens is when you insert a jack, or a cable into that jack, what it does is it spreads the two prongs apart from each other, as you can see there, and it breaks that part of the circuit. And at the same time, it then connects the center terminal of that right cable to the right input. So basically it breaks the parallel connection and inserts its own signal. So it's guaranteed that you either have a cable in this and its signal goes to the right channel, or you don't have anything and it copies the channel from the left to the right for mono support. And I think it's quite an elegant design. I wish it wasn't in the corner; it would be easier to see. I wish it also had 3 hands. That would also be nice. The reason why I mention this is, unfortunately, it's designed for the really long RCA jacks. So the ones that I have, the ones that everyone has seen look like this, but it's unfortunately is designed for ones that are quite a bit longer than this. They've went out of style. I mean, they don't make those really anymore. And the problem is this isn't long enough to get over the little hump that they put in the two wipers. So you push this all the way into the point where it engages, and then it sort of slides back out because of the spring force, and then those contacts close up, and you get mono again, and this doesn't actually make contact anywhere. So I'm either going to have to modify the jack such that it will accept a smaller RCA jack, which is, I don't really want to do that. It's going to be challenging to get it to work without being flaky. Or, also sort of challenging, is to find an adapter that has the really long RCA jacks and then converts it to something like a TRS, 3.5mm TRS, because I have an adapter that basically goes from 3.5mm TRS to literally anything else. So if I can have, this is the input, then that's fine with me. I just have to find a cable that does that, or make one. I mean, I may have to grab some really old, long RCA jacks I've got in a box somewhere and wire up my own. I feel like that might be the only way of doing this. So I just got back from my local electronics shop, and I really love their store because it's like 90% of the stock is from the year 1985. It's great because you can find stuff that they for certain don't make anymore, and it's all new, which is really nice. Although they have used stuff too. Anyway, so they happen to have terminal strips, which is exactly what I wanted for the replacement of the filter capacitors. Now I need 7 ungrounded lugs, and they only sold these 8 terminal strips, with 2 of them shorted to the mounting holes, which I'm obviously going to connect to the chassis, and the chassis is ground in this. This is it's ground, so obviously one of these wouldn't work, so I had to buy 2 of them, and I think what I might do is I might just cut one of them in half, and so I'll have basically 4 lugs, 3 of which are usable in one, and then the remaining 6 on the other. And when you put these on the side of the chassis, I'm not particularly happy with the clearance between the lugs and the side of the chassis. And we're talking, because these are right out of the filters, the voltage difference between these lugs and the chassis will be upwards of about 200 volts. And I know that technically that's totally acceptable, but I don't know, I'm just not too happy about it. So what I might do is I bought some just some metal standoffs, just so that I can mount it up a little bit, and hopefully that will be, that'll look much nicer. And I had to get some matching screws and nuts to go with it. So that's how I'll mount it. I'm not going to try and solder to this because, even though my iron is, I think, 48 watts, I'm not sure if I have enough power to solder to this. I need like a couple 100-watt iron to probably solder to this. I have one, I can get one, but I don't really think it's worth it. I think I'll probably just use nuts, and I'll probably Loctite them again, because I got to make sure that everything in this is vibration proof, because who knows what's going to be going on. So I think they'll mount quite nicely in here. I mean, this capacitor's going. I've reached the verdict that I think this is bad. I've tested it a bunch of times and it's fluctuating bad and good. So I think there's just it's just bad inside. So this'll go, and that'll basically free up everything from up here over. So I should easily be able to fit this strip here and then the other 4 underneath behind here. And then, of course, everything will get mounted on it. So, I mean, worst comes to worst, I have to mount this directly on the chassis. I'll maybe put like a nut or something in between to just raise it up by, you know, a tiny bit. In fact, that's probably what I will do. I probably won't use these spacers, but I thought I'd get them anyway, so I don't have to go back there. So once I get the capacitors, I will drill some holes, mount these, and I can get soldering. So I gave the design a bit more thought, and as you can see, I went back on pretty much everything I said I would do. So basically what I first started out by doing was just tracing out where the components were and where they were actually mounted in relation to the actual pins of the original multi-section filter capacitors, and how I was actually going to do the all the interconnects. And I don't know why, but I, for some reason, didn't realize that the cases of the filter caps are being used as ground. I'm not sure what I was thinking about that. So I thought, I mean, I looked for a better ground point that I could use, and I didn't really find one that was already here. So it sort of forced me to solder to the chassis. So what I did was, I mean, I'm happy with the clearances. I mean, they're perfectly fine for the voltages we're doing here. So I took these leads, which just run from the mains input through to the power switch for the treble control here, and I just unclamped them by bending these little metal clamps, pulled those out. I removed the plastic on this one because obviously it would melt when I tried to solder that. And as you can see, I was successful to solder these. So my my Solomon S20, which is a 48 watt iron, I cranked it all the way up, basically max heater on all the time, and it was capable. It was able to solder it, and I'm actually quite happy with the quality of those joints. I mean, these terminal strips are not going anywhere. I'm very happy with the quality of these joints. In fact, I think they're probably better than factory. So yeah, I was worried about that, but I'm very happy with these. The problem with the screws, of course, was just I wasn't going to get a good ground connection. Otherwise, I probably would have gone with them. But this way, you also don't get any markings on the outside of the chassis, so you can't tell that I installed this unless you actually open it up. And because there's a metal plate on the back, you're never going to see that. So I've ordered all the parts. They should come in a couple days. I just installed these now just to see if I would even be able to get any further when the parts even came in, because of course if I can't solder this, then there's nothing I can do until I get a better iron, and that might be about a week. So obviously it's possible. So I just gotta wait for those parts to come in, and now I know how everything's wired, so it should just be simply pop, 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 and we'll be good to go. We have parts. So my order came in. I got them from Mouser this time, because normally I order everything from Newark Element 14, but they recently pissed me off, and I've ordered from DigiKey before, but I can't actually remember ordering anything from Mouser. I probably have way long time ago. So I thought I'd do it again, and I mean, it arrived pretty quickly. It's definitely not as well packaged as Element 14. Not that, you know, you need to individually box with foam every individual part, but I don't know, I kind of appreciate it for the price you pay on the shipping nowadays. You better get that. So I'll just go over what I got. This order is 99% Panasonic capacitors, so they made a shit ton of money off me here. But when I recap something like this, I want to use a high quality capacitor. And so that means I'm going to use Panasonic, Nippon Chemicon, Cornell Dubilier, something like that. Really nice quality components. So I went with Panasonic on this. I like their stuff for audio. They seem to have the longest life of any capacitor that I've used. So generally that's what I go with. They're also very available. So all of the capacitors I have are 105 degrees C rated, and they all have a spec lifespan of 5,000 hours or higher. So they all, of course, well exceed the voltage rating that's specified in the document, in the schematic. So I've got a bunch for the power supply. That's what most of these are. I have a couple smaller ones. I thought, I might as, there's a few capacitors that I don't need to replace. They tested good, but I'm going to replace them anyway because it's really easy, and I might as well. I have some resistors. This, I believe, is one of the ones from the open cathode biasing circuit that I saw. These are really expensive caps for the power supply. This is, I believe, this is the 1.5K resistor on the outside of the power supply that's way out of tolerance, so I got a wire wound for that. All Vichy, of course, nice quality. More Panasonic power supply caps. I also got these. These are film capacitors. They're I think they're PET. These are by WEMA. These are for the crossovers, and the reason I went with this was because I couldn't easily get non-polarized electrolytics, like AC electrolytics, that with the right value and voltages. So I went for film instead. These should be perfectly fine. In fact, these should be better than the originals. These were pretty expensive though. Of course, they have really small leads, so I'm gonna have to make leads so that these will fit on those terminals. And I also bought some diodes. I bought a bunch of 1N4007s because I only have 1N4002s for some reason, and I mean, this is all I could find. This is my supply of 1N4002s. But these, as you might know, these are only 100 volt rated, and the circuit in the FM demultiplexer is actually 130 volts. So obviously you need a bigger diode. So I thought I'd buy these. And I also bought some fast diodes, so some really high-speed diodes that are also rated for high voltages. I think these are 600 volts. So just in case these perform weirdly, I thought I'd try these. I need these for another project, so I thought I'd get them in this order and then try them out and see what happens. So that's my haul. So I'm going to get soldering, and I'll update you, I think, when that's done.